Hi guys, welcome back to engineeringtalks.com. We already learned about Laplace transforms of derivatives and integrals in the previous video. Now let's get into the differentiation of Laplace transforms and solve problems on that. So happy learning, and don't forget to like, share and subscribe the channel and press the bell icon.
So the next topic is differentiation and integration of transforms. Today we will see the differentiation of Laplace transforms. It says that if Laplace of f of t is equal to f of s, then Laplace of t raised to n f of t is equal to minus 1 raised to n d raised to n by ds raised to n f of s, which can also be written as minus 1 raised to n f raised to n of s, where n can be 1, 2, 3, etc. Now let's solve a problem so that it will be clear to you. Here we have to find out the Laplace transform of t e raised to 3t. Now when we compare this with this, we find that f of t is equal to e raised to 3t and t raised to n is equal to t raised to 1. So n will be equal to 1. So first let's find out Laplace of e raised to 3t. Laplace of e raised to at is given by 1 by s minus a, right? So Laplace of e raised to 3t will be given by 1 by s minus 3 for s greater than 3. Therefore, Laplace of t e raised to 3t is equal to minus 1 raised to n. N is equal to 1 here, so minus 1 raised to 1. D raised to n by ds raised to n. Since n is equal to 1, we will have only d by ds here, of 1 by s minus 3. Therefore, we will have minus of d by ds of 1 by s minus 3, which is equal to minus of d by ds of s minus 3 raised to 1. Now d by dx of x raised to n is given by nx raised to n minus 1. So d by ds of s minus 3 raised to minus 1 will be given by minus of s minus 3 raised to minus 2. Therefore, this becomes equal to minus of minus s minus 3 raised to minus 2, which is equal to minus of minus becomes plus. So 1 by s minus 3 square. Now let's find out the Laplace transform of t square cos t. This is of the format t raised to n f of t, right? With n is equal to 2. So let's first find out the Laplace transform of cos t. So Laplace of cos t is given by s by s square plus 1. We all know that. So Laplace of t square cos t is given by minus 1 raised to n. N is equal to 2, so minus 1 square. D raised to n by ds raised to n. Since n is equal to 2, we have d square by ds square of s by s square plus 1, which is equal to d by ds of s by s square plus 1. Minus 1 square becomes plus 1, and we have rewritten this ds square by ds square as d by ds of s by s square plus 1. Now we have to find out the derivative of s by s square plus 1. So we can differentiate this s by s square plus 1 using the quotient rule. So according to quotient rule, d by dx of f of x by g of x is equal to g of x into d by dx of f of x minus f of x into d by dx of g of x by g of x square. So d by dx of s square plus 1 into ds by ds is 1 minus s into d by ds of s square plus 1 is 2s by s square plus 1 the whole square, which is equal to d by ds of s square plus 1 minus s into 2s is given by 2s square. So s square plus 1 minus 2s square by s square plus 1 the whole square, which is equal to d by ds of 1 minus s square by s square plus 1 the whole square. Now we will differentiate this function again using the quotient rule. So s square plus 1 the whole square minus d by ds of 1 minus s square, that is minus 2s, minus 1 minus s square into d by ds of s square plus 1 the whole square, that is 2 into s square plus 1, and we have to differentiate this s square again, that is 2s by s square plus 1 the whole square becomes a square plus 1 raised to 4. Therefore, it becomes minus 2 into a square plus 1 the whole square minus 2 into 2s is given by 4s. So, minus 4s into 1 minus s square into s square plus 1 by s square plus 1 raised to 4. Now, we can take this as common outside. So, s square plus 1 into minus 2s into s square plus 1 minus 4s into 1 minus s square by s square plus 1 raised to 4. Therefore, we will get minus 2s cube minus 2s minus 4s plus 4s3 by s cube plus 1 the whole cube after simplifying the equation. This is equal to 2s cube minus 6s, that is minus 2s cube plus 4s cube is 2s cube and minus 2s minus 4s is minus 6. So, 2s cube minus 6s by s square plus 1 the whole cube. Now, let's find out the Laplace transform of t square e raised to 3t sin ht. We have sin ht is equal to e raised to t minus e raised to minus t by 2, right? Therefore, e raised to 3t sin ht becomes e raised to 3t into e raised to t minus e raised to minus t by 2. Therefore, e raised to 3t sin ht is equal to e raised to 4t minus e raised to 2t by 2. That is e raised to 3t into e raised to t is e raised to 4t and e raised to 3t into e raised to minus t is e raised to 2t. So, e raised to 4t minus e raised to 2t by 2. Therefore, it becomes Laplace of t square e raised to 3t sin ht is equal to Laplace of t square e raised to 4t minus e raised to 2t by 2. Therefore, we will take this 1 by 2 outside since it's constant. So, 1 by 2 Laplace of t square e raised to 4t minus e raised to 2t, which is equal to 1 by 2. Now, we have t square here. So, n is equal to 2. Therefore, minus 1 raised to n. n will be equal to 2. So, minus 1 square d square by ds square Laplace of e raised to 4t minus e raised to 2t. Minus 1 square will be equal to plus 1. Therefore, 1 by 2 d square by ds square and Laplace of e raised to 4t will be equal to 1 by s minus 4 and Laplace of e raised to 2t will be equal to 1 by s minus 2. Therefore, 1 by 2 d square by ds square into 1 by s minus 4 minus 1 by s minus 2. Now, we can rewrite this as 1 by 2 d by ds of 1 by s minus 4 minus d by ds of 1 by s minus 2, which is equal to 1 by 2 d by ds of, now we will differentiate these two terms using the quotient rule and we will get minus 1 by s minus 4 the whole square minus of minus 1 by s minus 2 the whole square, which is equal to 1 by 2 d by ds of minus 1 by s minus 4 the whole square. Now, minus of minus becomes plus 1 by s minus 2 the whole square. Now, we will differentiate these two terms again using the quotient rule. So, 1 by 2 minus of minus 2 by s minus 4 the whole cube plus minus 2 by s minus 2 the whole cube. When we differentiate these two terms using the quotient rule, we will get these two terms. Therefore, it becomes equal to 1 by 2 into 2 by s minus 4 the whole cube minus 2 by s minus 2 the whole cube. Now, let's see how we can take the Laplace transform of t sin at. This is also of the format t raised to n f of t with n is equal to 1. So, Laplace of t sin at is equal to minus 1 raised to 1, that is minus d by ds of a by s square plus a square. Why a by s square plus a square? Because Laplace of sin at is a by s square plus a square. Now, we will take this constant outside. So, minus a d by ds of 1 by s square plus a square. which is equal to minus a d by ds of s square plus a square raised to minus 1, right? Now we'll get minus a into minus of s square plus a square into minus 2 into 2s. The 2s is the derivative of s square, which is equal to minus of minus becomes plus. So plus a into 2s by s square plus a square the whole square. So we'll take this s square plus a square raised to minus 2 to the denominator. So it becomes s square plus a square the whole square. Therefore, Laplace of t sin at is equal to 2as by s square plus a square. Now let's see how we can take the Laplace transform of t cos at. It is also similar to how we took the Laplace transform of t sin at. So Laplace of t cos at is equal to minus of d by ds of Laplace transform of cos at. Laplace of cos at is s by s square plus a square. So we'll differentiate this function according to quotient rule. So we'll get minus of s square plus a square into d by ds of s minus s into d by ds of s square plus a square by s square plus a square the whole square, which is equal to minus of s square plus a square minus s into 2s by s square plus a square the whole square, which is equal to minus of s square plus a square minus 2s square by s square plus a square the whole square. Therefore, we'll have Laplace of t cos at is equal to minus of a square minus s square by s square plus a square the whole square, which is equal to s square minus a square by s square plus a square the whole square. Please do like, share and subscribe the channel and press the bell icon. Thank you.